In our previous lesson, you saw how the Poisson distribution could be used as an approximation to the binomial distribution. On this one, we are going to see how the normal distribution that you learned last year as well can be used as an approximation to the Poisson distribution. And for that, I want to go to our first lesson. Remember back then when I told you that I was going to bring up the fact that increasing the value of lambda makes the shape of the Poisson distribution closer to the traditional bell curve, and I told you that I was going to bring that later. Well, this is it. So increasing the value of lambda means that this is going to be symmetrical, the shape is going to be symmetrical around the mean, all right? Which means that you should be able to use the normal distribution to describe the same thing, the same event. And when should this be used? Let's imagine that you want to calculate the probability that x is bigger or equal to, let's say, a very big number, 30, okay? And let's say also that lambda is a big number. So you will have a distribution that is symmetrical. If you just use the normal procedure using the Poisson distribution, you will have to calculate 1 minus the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 3 and continue until calculating the probability that x equals 29, right? Well, this is impractical. So this is where the normal distribution comes handy, because you can use instead the normal distribution. And if you do so, then you just have to figure out the z value for 29, and that will be it. Now, how can you use it? Let's go back down to our lesson. Here it is. You can use it when lambda is bigger than 15, when the mean is bigger than 15, and the normal distribution, which typically has parameters mu and sigma squares. So since now the Poisson distribution has the mean equal to the variance, which is the lambda, then what will the normal distribution boil down to? It will boil down to this. The normal distribution will have the parameters lambda and lambda, they are the same, and the z value is going to be given by x minus lambda over square root of lambda. So that's all that you have to do. If the Poisson distribution, again, has a mean that is bigger than 15, if you want, if you need, you can use the normal distribution with parameter lambda repeated, right? Because as you know, for the Poisson, the mean is the same as the variance, which is lambda, and apply what you learned last year about the normal distribution exactly the same way. And you can be confident that the result that you are going to get is the same that you would if you would bother to use the Poisson distribution in the circumstances that I told you a little while ago. So all the calculations are going to be similar to the ones you used last year, and that will be it.